Welcome to Study Loop.
Hi there. So for this problem, we need to calculate the net force that is produced in the wire 4 because of the other 3 wires. In this case, we are going to use the magnetic force that is in this point 4 and then sum all of the components. So what I'm going to do is to draw all the forces that the wire 4 feels because of the wire 1, 2, and 3. So to do that, we know that when two wires have the same direction in current, they attract each other. So in that sense, the force that feels the wire 4 because of 1 is in this direction to that wire. Now, the force that feels the wire 4 because of 3 goes to the left because feels um, it feels an opposite force because they have an opposite direction in their currents. So this is for 3, and the other one goes in the line that connect them, and this is also in the opposite direction because they have different directions in current. So this is for 2. So and the net force that it is filled in, or that we call it like this, is just the superposition of all of these forces that we will have for 1, for 2, for 3. And this angle in here is we can easily obtain it because we know that these wires form a square, form a square, and each edge has a length of 30.5 centimeters. So in that sense, this in here forms 45 degrees because it is half of 90 degrees. That is what it forms the x-axis with the y-axis. So we have that angle that we are called theta, 45 degrees. So we start by calculating each component of this F4 force. So the components that we are going to call it components. In this sense, we have the 4x component. So we are going to take into account only the forces that are acting on the x-axis, or at least have some component on it. So we have minus F for 3 because it is only in the component of that. So this is just that. And we also have minus 4, 2. And we can see that this angle in here corresponds to this angle in here. So it is also minus, but to obtain the x component, we need to multiply this by cosine of theta. So having all of this, we can apply the definition for the magnetic force. We know that that is given by the following. Nu sub 0, the current I squared 2 pi a for this case, because from point 4 to point 3, this distance is a, which is this, but we are going to call it a. So that's why we put this in here, minus the other one, epsilon 0 y cosine of 40 degrees, this value in here, and over the distance pi a times the distance to, oh no, okay, I'm gonna put it like this. The distance from the point 4 to the point 2, we can calculate it by just using the hypotenuse. We know that this in here is a, and we know that this in here is a. So the hypotenuse is the square root of 2 times a. And that's the thing that we are going to put in here. So that is 2 pi a, the square root of 2. So this is what we have for the x component of the force that is acting on the wire 4. Now we do the y component. So the y component, in this case, we write it like this. Or 1, because it only has the a vertical component, so it is simply that minus f2 sx42, and in this case the component is given by the sine of theta, because we want the vertical component. So it's sine of theta, and it is minus because it is pointing downward. So it is minus. And here we again apply the definition for the magnetic force. So in this first case is mu sub 0, and the distance to the wire 1 is also a, so it's 2 pi a minus the one from the and this is here. So we sum this. Oh, we can simplify these two expressions indeed. And in here we know that cosine of 45 is cosine of 45 is the square root of 2 over 2. So we can see that we are going to obtain, if we just put the value in here, we know that this is 42.2. So we can simplify this like this, and we will have 4 in the denominator. So when we sum this, we will have 3 and that's it for the x component. For the y component, we also know that it is the same value, cosine and sine of sine of 45 are the same values. So if we put that in here, sine of 45 is this. So we are going to obtain, in this case, okay, so that's what we obtain for these two components. Now, what we are going in trying to do is to obtain the magnitude of this force just by taking the square of these two expressions and then obtain the square root of all of this. So that's what we're going to try to do in here. So this is the square root of f for x to the square plus f for y to the square. And in this sense, we simply substitute all of that we have obtained. So for the x bar within minus 3, this to the square plus so we simply need to sum the inside. So in here, if we take the square root of what is inside is 9. And in here we will have, so we can see that we can just simply sum these two expressions and obtain this, and this will give us the same expression just times 10. So we will have the square root of 10 and the other just without this because they are like all elevated to the squared or to the squared. Oh, sorry, here they just. So is this for the magnitude of the force? And once we have obtained this, we can just simply substitute all of the values that we know. We know the values for mu sub 0, that's a constant. We know also the value of the current. All of these wires carry the same current, which is 7.5 amperes. And yeah, so putting those values, we know that the mu sub 0 is 4 pi times 10 to the minus 7 Tesla per meter over the over ampere, and the current is 7.5 amperes. And the separation between them, or the value of A, is just 0.135 meters. So putting all this into the calculator, we obtain 1.32 times 10 to the minus 4 newtons per meter. And we also want to obtain the angle of this vector force because we want we want now the vector. So for that we have the magnitude, but we need to calculate the angle with the positive x-axis. So to obtain that, we just simply want to call this p, and this, to obtain the angle, is the tangent of -1 of the y component between or over the x component, and this is tangent of -1, if we can see in here, we see that this and this are just, I mean, f of 4x is just minus 3 times the y component. So if we put that in here, we will obtain -1/3. So this is equal to 162 degrees. So with that, we just simply need to multiply the magnitude for some angle. So we obtain that the magnitude of the force is this, and the components are given by the cosine of 162 for the x part and sine of 162 for the y part. And this is equal to minus 1.25 times 10 to the minus 4 newtons per meter in the y component, in the x component. And for the other, we have obtained plus 4.17 times 10 to the minus 5 newtons per meter. So this is the net force that the wire force feels because of the other wires. So thank you.